This is our geometry lesson 7.3, triangle similarity, angle, angle, side, 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 and side, angle, side. Remember in chapter 4, we proved triangles congruent. There were 5 ways to do that. To prove triangles similar, there are only 3 ways that you need to know. So the first one is angle, angle. If 2 angles of one triangle are congruent to 2 angles of another, then the triangles are similar. So explain why the triangles are similar and write a similarity statement. Well, we could see that right here and here. We would have vertical angles. So we have angle, angle. And then our similarity statement would be ABC is similar to DEC. So make sure you line those up appropriately. All right. Explain why the triangles are similar and write a similarity statement. Well, so 2 right triangles, so that'd be 47. And that would be 43, which means we are good by angle, angle similarity. So then we could say triangle ABC is similar to triangle DEF. And there would be our similarity statement. All right, the next one, side, side, side. If 3 sides of one triangle are proportional to 3 corresponding sides of another, then the triangles are similar. So side, side, side works as well. And you have to show they're proportional, not the same. So and side, angle, side also works for similarity, showing that the sides are proportional and then the included angle would have to be the same. So those are the 3 ways to prove that triangles are similar. So verify that the 2 triangles are similar. Well, those 2 would go together. So 2 over 3, and those 2 would go together. 3 over 4.5. Those would all be proportional. So those are similar by side, side, side. Verify that the triangles are similar. Well, 2 to 1, 2 would go with 1, and 5.8 to 2.9. Those are both a scale factor of 2. The 70 is included in the angles, so those 2 are similar by side, angle, side, similarity. All right, explain why ABE and ACD are similar, then find CD. Well, you can see that we've got 2 right angles, and then they share A, so those would be similar by angle, angle. Then we've got to set up a proportion to find CD. Now remember, you got to think whole triangle. So that's a triangle, and that whole thing is a triangle. So I'm going to say 9 to 5 is this whole distance, 12 to x to solve. So take out my calculator, solve the proportion. 6 2/3 would be x. All right. All right, last proofs of the year here with similarity. When you're going through these, we're trying to prove these 2 triangles are similar. So they've already kind of set up proportions for us. We see that we have vertical angles here. And then we can see 3UT. This goes with this, and this goes with this as far as being proportional. So when you set these up, you want to go 3UT equals 5RT. Well, I want to get the numbers on one side and the letters on the other. So that would cancel and that would cancel. So 3/5 equals RT over UT. So that's my similarity ratio. I use division to do that. I could do the same thing here. Move the VT over there, show that they're both 3/5. So we would have it by side, angle, side. So let me clean that up here and walk you through it. So you can see that they did division. They're given division. They set it up to 5/3. If you did it for 3/5, that would be the same thing. And then vertical angles, and then side, angle, side. Okay. The photo shows a gable roof. AC is parallel to FG. Find BA to the nearest tenth. Now you got to make sure again that you are thinking in big triangle here. So this triangle and that is a triangle. Okay, so we're trying to find BF, which would be, or we're trying to find BA, so we have to find BF, which would be X first. So we can say 6.5 over 24 equals the short side, which would be x, over the whole thing, which would be x plus 17. So when you solve that, make sure you put it in parentheses. So I'm going to cross multiply 24x equals, distribute here, 6.5x plus, what's 6.5 times 17, which is 110.5. Subtract 6.5 from over there, 6.5x, so 17.5x equals 110.5. Divide that by 17.5, gives me x is 6.31. Add that to 23. So we're looking at about 23.31 feet. Make sure when you're setting up those proportions that you realize if you've got, you got to think the whole triangle here as you're setting them up. All right. Just like we learned that reflexive, symmetric, and transitive properties of equality have corresponding properties of congruence, they also hold true for similarity. So reflexive, symmetric, and transitive still work for us for similarity. All right, that is a wrap for section. Well, let's go through this proof here. 17, right here. All right. So given that CD equals 3AC, prove that those two triangles are similar. Okay. Well, remember, we're going to want to divide here. Well, first of all, we've got vertical angles. So angle ACB is congruent to angle ECD by vertical. All right. Then I'm going to divide both sides here by AC. So CD over AC equals 3. And CE over BC also equals 3. So that would be division. Okay, so we've got vertical, and then we've got CD goes with AC, and those two go together, so we can see that we've got side, angle, side similarity. All right, just another example of a proof for you as you're going forward with this. And this is the last proofs we'll see